Welcome Algebra 1. So we are starting chapter 2 today. This is going to be 2-1, which is solving one-step equations, which once I cut this out, I'm going to put that into my spiral. So we're just going to start off super basic with just one-step equations. So solving one-step equations just have, like you see below, they have a variable, they have an equal sign, equations. So to solve one-step equations, our main goal is to get the variable all by itself on one side of the equation. So let's write that down. So the goal is to get the variable all by itself on one side of the equation. We do this by using inverse operations, and we're going to talk about inverse operations below. Now, something that's really important with solving any type of equations, one-step, two-step, multi-step equations, what you do to one side of the equation, you must do to the other side of the equation. That is like really, really big, really important. So what you do to one side of the equation, you must do to the other side of the equation. And the reason is, so if you do something to one side of the equation to like use inverse operations to undo it, to get the variable all by itself, but you're also doing it to the other side, you're not changing the equation itself. You're just basically kind of rearranging it a little bit. So that's why this is super important. If you don't do it to both sides of the equation, then now you're actually like changing the equation itself, and you're like making an entirely new problem. So it's super, super important that you remember whatever we do to one side of the equation, we're always going to do to the other side. Now let's first talk about inverse operations. Inverse operations are operations that undo each other. So they're kind of like the opposites of each other. If I have addition, which is plus, what's the opposite of addition? Well, the opposite of addition we know is subtraction. So if I have something that's adding, to undo that, I would subtract it. Now, vice versa, if I have something that's subtracting, to undo it, I would add it. Now, the inverse operation of multiplying, so when I multiply, the opposite of multiplying is to divide. So when I see multiplying, I know that the opposite, or the inverse operation is division. Now the other one that we're going to deal with, and these are really the only ones that we're going to be dealing with, are going to be something when we have an exponent, like a square. So when I raise something to the second power, to undo that second power, the opposite of squaring something is square rooting something. And vice versa. To undo a square root, you would square both sides. We're not going to deal with that too much. We're primarily going to focus up here, but it's something to mention and it's important. So let's get into some examples. So my first example says 15 plus s equals 42. Now, the goal of solving one-step equations is to get my variable is my letter, to get that letter, that variable, all by itself. So my variable here is s. We want to get that all by itself. So what's on the same side of the equal sign? Now, one thing I do to kind of help me to make this clearer is I always will draw a line down my equal sign. Now, the reason why I do this is when I am trying to get s by itself and I need to move the 15 over, I'm always thinking about back up to my big rule up here. What you do to one side of the equation, you must do to the other side. So to move this 15 to the other side of the equation, This is a positive 15. So to move that positive 15, it's adding. So to undo that, we're going to subtract 15. Because 15 minus 15 is 0, so that's going to go away. Now remember, if I do it to this side of the equation, I have to also do it to this side, which is where that line kind of helps us. So we're going to subtract 15 from both sides. Now 15 minus 15, that's 0. It goes away. That's what we wanted. And then S, that S is just going to come down. And then 42 minus 15 is 27. So now S is by itself, and that's my answer. Now, how can I check my work? I can always just check my work by plugging this back in. If I plug in 27 for S, that would just be 15 plus 27. And does 15 plus 27 get me 42? It does, so it works. Okay, so what I want you guys to do is use number 1, and I want you guys to try 2 on your own. 2 is very similar. You have x plus 13. You're trying to solve for x. So think about what you need to do to get x by itself. Okay, so hopefully you've already tried it on your own. You're now just watching to see how we do it. So this plus 13, we want to move it to the other side. Before I do anything, I'm going to just draw my line to remind me whatever I do on this side, I have to do on this side. So if this is a plus 13, I'm going to subtract 13 from both sides. And then I have x comes down. 13 minus 13 is 0. And then 21 minus 13 is 8. So x is now by itself, and I have my final answer. Okay, so let's look at 3. So we have a minus 12 equals negative 8. Again, we're solving for a variable, so we're trying to get a by itself. So I'm going to start by just putting my line down. I want to get a by itself, so I have to move that minus 12 to the other side. It's a negative 12, so I have a minus sign. So to undo minus, I'm going to add it. So I'm going to add 12 here, and then I'm going to add 12 to the other side. Whatever we do to one side, we have to do to the other. So that a comes down. It's now by itself. Negative 12 plus 12 is 0. That's what we wanted. And then negative 8 plus 12 is 4. A is by itself. We solved it. And again, you can always check your work. If I plugged that back in, 4 for A, 4 minus 12 gets me negative 8, which is what it is here. So you can always check your work with these. That's the beauty of these types of problems. Okay, so what I want you guys to do is try 4 on your own and then come back and see how you did. First step, I drew my line down the equal sign. If you don't want to do that, you guys don't have to do that. It just is like there to kind of keep you organized. Now my goal is to get m by itself. So that negative 13 was on the same side. So I added 13. The opposite of a negative is a positive. So I'm adding 13 to both sides. Negative 13 plus 13 is 0. The m comes down. 17 plus 13 is 30. And so m is equal to 30. Okay, so number 5, we have negative 6x equals 30. Now remember, our goal here is to get the x by itself. Now when you have a number and a variable attached like this, there's no operation in between. We can always assume that actually what's happening is that they're multiplying together. So this is like negative 6 times x. So the opposite of multiplication, to undo multiplication, what we're going to do is divide. So I'm going to draw my line. And then to undo the negative 6, I'm going to divide this side by negative 6 and this side by negative 6. Now, what is negative 6 divided by negative 6? Well, that's 1x, which is what we want. And then 30 divided by negative 6 is negative 5. And so I get x equals negative 5. Again, you guys can check your work. What is negative 6 times negative 5? Positive 30. Perfect. Okay, so try number 6 on your own. Come back, see how you guys do, and we'll continue. First step, I drew my line. I'm isolating the X, so it just kind of helps me to visualize it by highlighting it. So now that, remember, they're right next to each other, so that means they're multiplying. So to undo the multiplication, the opposite of multiplication is division. So I'm going to divide both sides by -7. -7 divided by -7 is 1, 1x, that's what we want. And -42 divided by -7 is +6. So x equals 6. Okay, last two are fraction. So we have 2/5 x equals 8. Now there's a lot of different ways that you guys can do this. You can do this in one step. You can do this in two. I actually prefer to do this in 2 steps. If you prefer to do this in one step, the easy way to do this is by multiplying each side by the reciprocal. The reciprocal of 2/5 would be 5/2, so you can multiply this side by 5/2 and this side by 5/2. But like I said, I prefer to do it in 2 steps, so I'm going to show you guys that method right now. So I actually rewrite this. This is the same as 2x over 5 equals 8, because the x is really like x over 1. So the 2 and the x are on top, and the 5 is by itself on the bottom. So our goal, again, is to get that x by itself. So the first thing I'm going to do, besides just drawing my line down the middle, is I want to get rid of what's in the denominator. Now that's being divided by 5. So if we go back up to our inverse operations, the opposite of dividing by 5 is multiplying by the same number. So what I'm going to do is I'm going to multiply both sides by 5. Now 5 divided by 5 is 1. So 1 times 2 just leaves me with that 2x equals, and then 8 times 5 is 40. Now I still need to get x by itself. And so now we're at the same point we were with 5 and 6. We want to get rid of that 2. It's 2 times x. So to undo that 2, we're going to divide both sides by 2. And I get 2 divided by 2 is 1, so x. And then 40 divided by 2 is 20. So again, if you would have preferred to just do it in one step, you can multiply both sides by 5/2, which is essentially what we did. We just broke it up into 2 parts. Okay, so number 8 is really similar. First thing I'm going to do is just rewrite it. So it's 1x over 3 equals -10. Now that 1x, we really don't need that 1. So actually this is exactly one step. We don't have to do the 2 steps because the 1 is what we want. We want it to be 1x. So what I'm going to do is first get rid of what's being divided. To undo division, we always multiply. So I'm going to multiply both sides by 3. I have 1x, which I don't need to write the 1. So I'm just going to write x equals -10 times 3, which is 30. And that's my final answer. Oh, not -30. Yes, -30. It's like I didn't have it everywhere. Okay. Remember, you guys can always check your work by plugging it back in. If I go into my calculator and I did 1/3, sorry, that was supposed to be divided, 1/3 times -30, I would get -10, which is what I have here. So it's an easy way to check your work. Okay, so I glued my notes into my spiral, and we're actually going to continue on to 2-2 since 2-1 is kind of a quick little section there. And 2-2 is just taking it one step further to 2-step equations. So I'm going to actually continue and just put this in my spiral on a blank piece of paper. So we are moving on to 2-step equations, which is what I'm going to title this one. Okay. So 2-step equations, what I'm going to do, there's really not that much more to it, but what I'm going to do is I'm going to put an example on the left side and then kind of some extra steps on the left hand or on the right hand side. So let's start with an example. So if I have 6x plus 8 equals 50, your first step here, let's zoom in a little. Just like with the two-step equations, your goal here is to get x by itself or get whatever variable we're looking at all by itself. So my variable here is x. Now I'm still, just like I did before, I'm still going to put my line down the equal sign. So let's start there. Okay. So I just put a line down the equal sign. So our first step, our first mathematical step, is to undo any addition or subtraction that's happening on the same side as the variable. So that's going to be the first thing I'm going to do. Undo the addition or subtraction. Sorry, I spelled addition poorly. Okay, so to undo the addition or subtraction, I look on my side that has the variable. And so what's being added on this side? Well, it's that plus 8. So that's the first thing I'm going to undo. And what we're really undoing is the order of operations. So we have GEMDAS, right? So the first thing, like when we're simplifying, is grouping exponents, multiplying, dividing, and then adding and subtracting. So when we're undoing it, we're going in the opposite direction. So if we have this plus 8, the first thing I'm going to do is I want to move this to the other side. So to undo a positive, we're going to subtract 8 from both sides. And then we'll write our new equation. So 6x, I'm just going to bring that down. 8 minus 8 is 0. And now 50 minus 8 is 42. So now that I undid any addition or subtraction, my next step is to undo the multiplication or division. So let's do that next. Undo the multiplication or division. So the 6 is being multiplied. Remember, when the 6 is, or the number is next to a variable, it's multiplying. So to undo that multiplication, we need to divide both sides by 6. 6 divided by 6 is x. That's what we wanted. And then 42 divided by 6 is 7. Now x is by itself. We have our solution. Now again, just like I was saying in the other one, let's talk about how we can check. And so let's write that down. So to check, bless me, excuse me, sorry. Okay, so to check, we plug the solution back into the original equation. Okay, so let's look at checking, and then we'll do some more problems. So my final answer was 7. So if I were to check that, how I would do that is I would just do, okay, so 6, and then in place of 7, we're going to put, in place of x, we're going to put 7 plus 8 equals 50. And then I would simplify that. I'd use my order of operations to simplify. So 6 times 7 is 42. 42 plus 8 is 50. And that makes sense. 50 equals 50. So I did it correct. If these two don't equal each other, you've done something wrong. Go back, check your work. Okay, let's try some examples. Okay, we're just going to do 5. Okay, so number 1, we have 2x minus 5 equals 11. First thing I'm going to do is I'm going to put my line down the equal sign to just kind of keep me organized. And then again, if you guys need to highlight the x, highlight the x. If you don't need to, don't do it. Okay, so just like above, my first step is to undo any addition or subtraction that we have on the same side as the variable. I have a minus 5 over here, so I want to undo that. Remember, the opposite of subtracting is adding. So I'm going to add 5 to both sides of the equation. So that 2x is going to come down. Negative 5 plus 5 is 0, which is what we wanted. And then 11 plus 5 is 16. Okay, we keep going. So now we still need to get x by itself. And we do that by undoing the multiplication or division. So this is 2 times x. And so to undo that, we're going to divide both sides by 2. So 2 divided by 2 is 1x. That's what we want. 16 divided by 2 is 8. So my answer here, final answer, is x equals 8. You can always plug it in by checking. 2 times 8 is 16. 16 minus 5 is 11. You can just do it in your head like that. Pretty straightforward. Okay, but again, remember, if you guys have any questions while we're going through this, you guys can always bring them to class, whatever day we see each other, and then we can go over those questions in class. That's going to be the best way to get the help that you need. Okay, let's try a second problem. So I have 13 equals negative 4x plus 9. Okay, now I'm going to draw out my line to start. Just start there. And then what I want you guys to think is, what would be the first step you would do if you were solving this on your own? So what's your first step? And if you said subtract 9 from both sides, you would be correct. So I'm going to subtract 9 from here, and I'm going to subtract 9 from here. This is a little different because the x is now on the right side versus the left side. It doesn't change how we do things. So 13 minus 9 gets me 4. This negative 4x is going to come down. 9 minus 9 is 0, which is what we wanted. Now I still want to get x by itself. So to do that, remember this is negative 4 times x. So think to yourself, what am I going to do to get x by itself? And if you said divide both sides by negative 4, you would be correct. We are dividing by negative 4 because we want this to be x by itself, or just 1x. So it's 1x, not a negative 1x, it's a 1x. So negative 4 divided by negative 4 over here is 1, which is what we wanted. 4 divided by negative 4 is negative 1. And so negative 1 equals x, or x equals negative 1. Again, you can always plug it back in to check your work. Okay, let's bring in some other stuff. So for number 3, let's do x divided by negative 5 plus 8 equals 11. Okay, first step, I'm just going to put my line down to signify each side of the equal sign. And then I'm thinking, okay, what am I going to do first? So what would be your first step here? We want to get x by itself. And if you are thinking, I'm going to subtract 8 from both sides, you would be correct. We want to undo the addition or subtraction. So we have an adding 8. So the opposite of adding 8 is subtracting 8. So I bring this x over negative 5 down. 8 minus 8 is 0. And then 11 minus 8 is 3. Okay, so then my next step is to undo the multiplication or division. Now with this, I have x divided by -5. So how am I going to undo this division on this left side? Well, the opposite of division is multiplication. So to undo the division, I'm going to multiply both sides by -5. Because -5 divided by -5 is 1. Again, that's what we want, 1x. And then 3 times -5, remember we're multiplying, so 3 times -5 is -15. So my final answer, -15, I can plug it in back into the equation, see if I get the same answer. You should. Always a good option for checking your work. Okay, let's move on to our fourth example here. So number 4, 7x over 4 minus 10 equals -38. This is actually going to be a three-step equation, yep, but still kind of hand in hand. So first thing I'm going to do is draw just my line down the equal sign. I just like to do that to keep myself organized. And then I'm thinking, okay, what is my first step? So you're thinking, what should I do first to get x by itself? And if you're thinking add 10 to both sides because we want to undo the addition and subtraction first, you would be correct. So that 7x over 4 is going to come down. -10 plus 10 is 0, which is what we want. And then -38 plus 10 is -28. Now I'm at a similar problem that I was in my one-step equations where we were talking about fractions. So you can undo this two ways. You can multiply it by the reciprocal, or you can take it part by part. So I'm just going to take it in 2 steps. So I'm first going to undo what's being divided, which is the 4. So to undo division, I'm going to multiply both sides by 4. Because 4 divided by 4 is 1, and 1 times 7 is just 7x. And then -28 times 4, I'm going to plug that into my calculator, is -112. And now we're at a similar problem that we were in 1 and 2 and our example problem. So to get x by itself, we have that 7 in front of it. Remember, it's multiplying. So to undo multiplication, we divide both sides by 7. And so -112 divided by 7, again, I'm just plugging that into my calculator. I get x is equal to -16. Okay, last one that we're going to do. So number 5 is going to be our last example here. So we have x minus 13 over -6 equals 5. So this one is a little different. So when there is like an entire expression like this divided by a number, we actually need to get rid of the denominator first. So this goes a little out of the ordinary of our normal like add 13, divide, then like undo the multiplication division. And that's because the entire expression is divided by -6. So let's actually make a note. I'm going to put that up here. So when there is an expression divided by a number, you need to get rid of the denominator first by multiplying. Now, the reason why is because this 13 is also being divided by that -6 too. So it's easier just to get that out of the way first. So to undo this dividing by -6, that whole thing that's being divided by -6, I'm going to multiply both sides by negative 6. And what happens, negative 6 divided by negative 6 is just 1. We can draw our line down the center there, and then it's just 1 times x minus 13, which is just x minus 13. And then 5 times negative 6 is negative 30. And now it's a really straightforward problem. It's just that one-step equation. So we undo anything that's being added or subtracted on the same side, which is that negative 13. I'm going to add 13 to both sides. And I get x equals, so negative 30 plus 13 is negative 17. And that is my final answer. And that is all we're going to do for 1 and 2-step equations. So if you guys have any questions, please make sure you're bringing them to class. We're starting to get into the most important stuff. This is something we kind of do over and over and over in all of our units. So it's really important that you guys get that strong foundation for this section. So when we're doing more complicated stuff, you feel like this stuff is easy. So if you guys do have any questions, bring it to class so we can talk about it. And I will see you guys soon. Bye, guys.